All right, so now moving on to a question that is paired products, and this is an SQL question. So let's first read through the question. Right, so let's say we have two tables, transactions and products. Hypothetically, the transactions table consists of over a billion rows of purchases bought by users. And now we are trying to find paired products that are often purchased together by the same user, such as wine and bottle openers, chips and beer, etc. Write a query to find the top 5 paired products and their names. And basically, for the purpose of satisfying the test case, P2 should be the item that comes first in the alphabet, and the quantity column represents paired products count. This one. This is the paired products count. Right. So this is, for example, the input transactions table is given in this format. We have column ID. We have 5 columns: ID, user ID, created at, product ID, and quantity. All are integer except created at, which is a date type of a date time format. And this is the transactions table. And then we have the products table, which has column ID, name and price, and integer, varchar, and float types. Output is in this format, and we have this example. Let's see the example. So, for example, we have inputs. This is the input, right? This is first input that we have. For products table, this is products, and then we have the transactions table. And the output coming is this P1 and P2. These are the paired products. So let us see first the user ID that is common. So let us see a user ID. We can see jelly and peanut butter are the two paired products. That would mean that since we are looking at since we want paired products that are often purchased together by the same user, right? So we would be wanting to extract those products, that is those pairs of products that have been bought by the same user. So let us see user ID is 50. This is 50. So product ID common, we can see 1 and 10. And in products we see 1 is peanut butter. The product with ID 1 is peanut butter, and with product ID 10 is jelly. So here you can see you can match P1 and P2 are the paired products because they have been bought by the same user. Similarly, you can see user ID 30. So these are the products 2 and 9. So you can see 2 and 9. 2 is chips and 9 is dip. So 2 and 9 would go together, chips and dip, right? And similarly, you can see all the other examples. You need the quantity, that is the combined quantity, which you can see this is 5, right? So you just need to return the combined quantity. So let us go through the solution. So basically, we are tasked with finding pairs of products that are purchased together by the same user. So before we do anything, we need to join the two tables so as to access the product IDs and the user IDs. So we join on the product ID because that is common in the two tables. So we can associate each transaction with the product name. So this is the code for that. Select user ID, comma created at, comma products.name from transactions. Join products on transactions.product ID is equal to products.product ID, or you can say just ID. Because in products, it is named as the product ID is just named ID. Afterwards, we are faced with the first challenge of selecting all instances where the user purchased a pair of products together. One intuitive way to accomplish this is to select all the created at dates in which more than one transaction occurred by the same user ID, which would look like. So let me show you how it would look like. Select user ID, comma created at, comma products.name. All of this remains the same. From transactions, join products on transactions.product ID is equal to products.id. Now we add where transactions.id not in, and we have a subquery here. Select ID from transactions group by created at user ID having count star greater than having count star equal to 1. This means that we select all created at times or dates in which more than one transaction occurred by the same user ID. So we are saying where transactions.id not in. So that means a count that would be greater than 1, or that is a count in which we have the same user purchasing two different types of products. So in transactions, we would basically from this subquery we get all the created at dates in which more than one transaction occurred by the same user ID, and then we return, then we select it. So this is an acceptable way to accomplish the task, but it runs into trouble in the next step where we will need to count all the unique instances of each pairing of products. Fortunately, there's a clever solution which handles both parts of the problem efficiently. So we can try cell joining the combined table with itself, and then we can specify the join to connect rows sharing created at and user ID. So this is the syntax of that. You can see with purchases as select user ID, comma created at, comma products.name from transactions, join products on transactions.product ID is equal to products.id. So this same code that we have here, we just use an alias name, that is purchases, right? So select t1.name as p1, t2.name as p2, comma count star from purchases as t1, join purchases as t2, right? So we are basically the table that we have, we are self joining the table, the combined table, we are self joining it. We're self joining the combined table with itself. We can specify the join to connect rows sharing created at and user ID. And we just join on t1.user_id is equal to t2.user_id and t1.created at is equal to t2.created at. So this means that the user ID should match. That means the same user the ID of the user is same. So the same user is purchasing two different or more than two different products, and it is the person or the user is buying it at the same date. That is t1.created at the date is equal to t2.created at. So the self join produces every combination of pairs of products purchased. However, looking at the resulting section, it becomes clear that there's an issue. Right here, we can see we are including pairs of the same parts in our selection. To fix this, we add and t1 dot name less than t2 dot name. One additional problem that this solves for us is that it enforces a consistent order to the pairing of names throughout the table, namely that the first name will be alphabetically less than the second one, that is a less than z. This is important because it would avoid the potential problem of undercounting pairs of names that are in different orders, that is a and b versus b and a. Finally, we can then finish the problem by grouping and ordering in order to count the total occurrences of each pair. So this remains the same, the alias. Then this happens, and then we have added the condition and t1 dot name less than t2 dot name, group by 1 comma 2, order by 3, descending to ascending, limit 5.